still need to finish this first handout. Page number 2. I talked about, I wrote about correlation research. Let me briefly discuss what we mean by correlation research. If you guys can recall these biological theories, especially where people talked about physical features and criminal behavior, starting with Lombroso, Charles Goring, Ernest Houghton, and William Sheldon. What these people, what did they do? Do you recall any of these people? What was Lombroso's idea?
Wasn't it had to do with eyes and nose, ears?
Yeah, basically he looked at 37 physical features which we can see from outside, and there were problems with his studies because he studied only prisoners in Italian prison. Now, prisoners are not the only offender population, they are part of the whole offender population. So he did not look at offenders who were living in the community. His study was partial, it was not complete. Second thing, he talked about all kinds of strains. Remember, he said that people are atavistic, meaning we are, those criminals, they are not normal human beings like us. Supposedly we are normal. So they belong to an earlier species of Homo sapiens. So what kind of things he talked about, like high cheekbones, long arms, receding chin, large forehead. So if you can recall our forefathers, how they look like, his idea was because of those physical characters, those people are biologically predetermined to be criminals. So what did he do? In order to do his study, he looked at two things. So physical features and criminal behavior. What he did, he collected data and then he did some statistical analysis. The statistical analysis he did, that was looking at the correlation between this one and this one. So the issue was how these physical features, they were correlated to their criminal behavior. And what was the problem? All he found that they were statistically correlated. That means the statistical correlation between these and these, they were significant. But he interpreted that correlation as causation. That means this is causing this. That is totally wrong. So if you look at correlational studies, the main idea is you are looking at two or more different things, and all you are trying to do is to find out whether there is a statistically significant correlation between those things. That's all you are doing. So that significant statistical correlation never indicates that this is causing this. So it is not causation, never. So that's a wrong interpretation of correlational studies. Okay? And this last part we have math reviews. Let's briefly go over these. Rounding. Okay, what kind of situation you are going to round and how you are going to round. Let's say you are looking at an average age and it came to about 31.6, and another age 32. 3. How are you going to round up this one and this one?
Around 31.6 and 32.
31.6, we are going to round it up to 32, and then 32.3,
Round down to 32.
round down to 32. So the idea is, if the number after the decimal point is more than 5, you go up. If the number after the decimal point is less than 5, then you go down. Are you guys with me? So that's how we are rounding. Okay, next part is proportion and percentage. Okay, let's say we have 50 people in this class. So our N is 50, and we have (20) men and 30 women. This is a better one. Those of you who are going to Croatia, that percentage is just completely skewed. If you have 50 people in that class, number of men may be 3 or 4, or rest of them are all women. It's completely skewed. So if the total is 50, number of men is 20, how do you calculate that proportion of men? So proportion in this case will be what? 20 divided by 50. So how much? 0.4? So the proportion is 0.4. Proportion of men. So we'll write proportion of men equal 20 over 50 equal 0.4. That's the proportion. How do you convert a proportion into percentage? Anybody?
You move the decimal point 2 places. Move the decimal point 2 places. This is by 100. And
You multiply that proportion by 100. So if we are, then we will write percentage of men equal 0.4 multiplied by 100 equal 40. So that's the difference between proportion and percentage. What else? Summation. When we are using statistical symbols, or we are saying summation, what is the sign we normally use for summation? That's the sign sigma that indicates summation. What is this one?
Omega?
No. Omega is, that's not omega. Look at the watch, omega. That's omega. It's been a long time. That's also sigma. But we use this sigma when we are dealing with variance or standard deviation. Then we use this sigma. But in terms of summation, we write this one. And that's all about